Topic for today is horizontal curves, the first of which is simple curves. So this is what a simple curve looks like. You have this. So we use this for uh, roads, highways, etc. When you see a curve along the road, it employs this. So there are several parts to a simple curve. You have your point PC and PT. So those are your point of curvature and point of tangency. So point of a curvature is the beginning of the curve. Point of tangency is the end of the curve. You have your PI, which is point of intersection of the tangents. It's also called the vertex. So you have these two lines as the tangents. We call them that because they are tangent to your curve. Okay. So the point of intersection of those two is your point of intersection. And then the angle between them is what you call I, which is intersection angle over here. So intersection angle, also called deflection angle and central angle, is the angle of intersection of the tangents. So once again, we got two tangents over here, point of intersection, PI, and this is angle I, which is intersection angle. The angle subtended, it is also the angle subtended by PC and PT at O is also equal to I, where O is the center of the circular curve. So this is your O, that's the center of this curve. So imagine this as a circle, part of that. This is an arc, and this is the center of your circle, O. Okay? And the angle subtended by PC and PT is equal to I as well. So this is angle subtended by PC and PT. So here, this I, this also equal to I. Okay, later on, I'll show you the relationship between all of those parts. Next, your tangent. So it's the length of tangent from PC to PI and from PI to PT. So PC to PI, PI to PT. For a simple curve, those tangents are equal. Okay, so T and T, they're the same value. Next, radius, R. Simply put, it's the radius of your simple curve. You already know what that is. Next, capital L is the length of chord from PC to PT. PC to PT. This straight line is your chord, length of chord. And then point Q, as shown, is the midpoint of L. So here, this point Q, capital L is the length of chord. So Q is midpoint of that, therefore it bisects your chord into two. So this is L over 2, this is L over 2. Next, we have length of curve from PC to PT. So this is the curved line from the name itself. Point M in the figure is the midpoint of LC. Okay, so students often interchange this length of chord and length of curve. Length of chord, capital L, length of curve, LC. Okay, so remember the difference between the two. Length of chord, a straight line. Length of curve, curved line. Okay, midpoint of chord is Q. Midpoint of curve is M. Next, we have what we call external distance. It's the nearest distance from PI to the curve. Here, this is your E, external distance. This is your PI. And shortest distance to curve over here. So this line has distance E, external distance. Next, M, mentioned earlier, we call that the middle ordinate. It's the distance from midpoint of curve to midpoint of chord. So we have your Q here, right? This is your M. Q and M are the midpoints of your chords and curve respectively. Distance between the two is M. We already know I. Next, X, offset distance from tangent to the curve. Note X is perpendicular to T. Yan. Offset distance from tangent to curve. So again, this is your tangent. Given an offset deflection angle theta over here, you'll get this chord. So the distance of that tangent to the curve is X. Over here, this line. And next, and as mentioned earlier, theta, deflection angle, or also known as offset angle from the tangent to any point on the curve. So we have deflection angle. Usually it's from PC. It could be from PT, but basically it's an angle from the tangent to any point on this curve. Deflection angle is used in establishing the actual curve, which you would have known in the fieldwork activity for surveying 2. Unfortunately, you don't have that, so you won't be able to demonstrate how to create a horizontal curve such as your simple curve. But that's the purpose of the deflection angle. It's to set up the points to create this simple curve. Next, degree of curve. So they're different, okay? Deflection angle from tangent to any point on the curve. So that's your theta. Degree of angle is the central angle subtended by an arc if you're using arc basis, or chord if we're using chord basis of one station. In English system, one station is equal to 100 feet, and in standard unit, your one station is equal to 20 meters. So later, I'll show you what arc basis and chord basis are, which are the methods we use to get the degree of your curve. So degree of curve isn't shown here, okay? It's not really a part of this simple curve. Well, it is, but it's a very small portion, which again, I'll show later. And then, finally, you have your C sub 1, which are subchords. It is the chord distance between two adjacent stations. So for example, this PC is a station. If we get another point here, that's another station. Joining the line between them, that's a chord. For example, here, okay, there was a station established here. Again, deflection angles are used to get points on a curve. Those points are called stations. So let's say there's a station on this point. So the distance from PC to that station is a subchord. And this is your long chord. Okay. All right. So those are the parts. And these are the equations of those parts. So external distance, tangent distance, middle ordinate, long chord, length of curve. And as you can see here at the bottom, the equations for your degree of curve and how to get your stations. So let's do that. Let's derive how we got those equations. Okay. So let me just open this up. Okay. Okay. So let me explain how we got all of those equations. First, we have this simple curve. Okay. Simple curve. So first, let's consider this triangle. Okay, over here. So since these are the radius of your circle, these are tangents to your circle because this simple curve forms an arc of that circle. Remember, radius is perpendicular to the tangents. So as you can see, these forms right angles. And then we have this right triangle. Okay, from that we can create an equation. Okay, so first, let's figure out if we can isolate that. And so perpendicular. Yeah. Okay, so this length is r. This is r because it's r, right? Plus e. And then this is tangent length P. Now let's figure out what this angle is. Okay? So to get that, recall this entire thing is also I, right? This line actually bisects your curve and your chord, which also means it's bisecting your angle. Okay, once again, this line passes through Q and M, which bisects your chord, long chord, and curve, which means this also bisects this angle, meaning dividing it into two. Therefore, this angle is just I over 2. Okay? Now, using trigo functions, we can create an equation for E by using cosine. So cosine theta, and theta is I over 2, equals adjacent, which is R, over R plus E. Okay? Solving for E, we get, okay, so dividing R by this, so we get R over cosine. 1 over cosine is secant, right? So this becomes R secant I over 2. Okay, so that's R plus E equals R secant I over 2. I only need E, so I'm just going to transpose R to the other side. So this is minus R. I'm going to factor out R, so we get E equals R times secant I over 2 minus 1. And that's how you got the equation for external distance. Okay. Next, let's get tangent distance. To do that, we'll use the same triangle. So tangent I over 2 equals, so opposite over adjacent, so T over adjacent R. Therefore, T is just R tangent I over 2. And so that's how we got T. Next, let's solve for M. Okay, to solve for M, let's consider R minus M. Okay, this. Okay, so this one. Right. So this is L over 2. This length, since this total length is also radius, this is M. So what's left is R minus M. And then this is still R. Okay? So using cosine, so this angle is the same, it's the same thing here, right? That's also I over 2. So let's use cosine. I over 2 equals adjacent, which is R minus M over hypotenuse R. Okay? I'm going to multiply both sides by R, so you'll get R cosine equals R minus M. I only need M. So I'm going to transpose that to the other side. So M equals R minus R cosine I over 2. I'm going to factor out R. So M equals R 1 minus cosine I over 2. Okay, so that's the equation for your middle ordinate. And next, L. Okay, so using the same triangle, let's use sine. So sine I over 2 equals opposite over hypotenuse. Opposite is L over 2. Hypotenuse is R. So L is just 2R sine I over 2. Okay? And then finally, length of curve. Once again, I've been saying this is a part of a circle. Can anybody give me the equation for arc length of a circle? Very good RDL. It's R theta. Also, John. Okay, so recall, S equals R theta, or S is an arc of your circle. Remember, the simple curve is also an arc of a circle, and our label for that is LC, length of curve. Okay, R is this capital R, radius of your curve, and theta is this, right? And that theta is I. So rearranging things, LC equals IR. So that's it. And that's the equation. Next, our degree of curves. Okay, let's talk about that. So degree of curve just shows how much your curve is bending, how straight or how curved it is. So the higher the degree of curve, the steeper the angle. Could be this or very flat or almost flat. Okay, so that's the degree of curve. Now, we have arc basis. So for arc basis, from the name itself, we consider the arc to be equal to 20. And the angle subtending at that is your degree of curve. Okay, so this is R, this is R. So we're going to take a 20-meter length of the curve. Okay, for example, this length is 20, and then we're going to figure out the angle subtending that. Okay, and then to solve for that, you can just use this, S equals R theta. S is 20, R D. Okay, theta is D. So that's your how to get degree of curve using arc basis. Okay, and chord basis from the name itself, once again, uh, from the name, again, instead of the arc being 20, the chord is what's 20. And again, the angle subtending that chord is your degree of curve. So in case you're wondering, subtending basically just means the angle opposite the angle covering that curve. So opposite to 20, opposite to 20. Okay? Because I've been using that a lot in this topic. And then, of course, both sides are R. So here, instead of this degree is 2, if you're going to join two straight lines, a chord in essence, okay, not the curve, okay, a chord. So you can see that here. It's very small, but 20 straight line, get the angle subtending that. That's your degree of curve. Okay, this. To solve for this, we're not going to use that straight line. I'm going to use your angle bisector. Okay, remember angle bisector divides everything into 2, meaning if this is 20, this length is now 10, and this angle is now d over 2. Okay, and then we're going to use trigo function, so sine, because we got this right triangle over here now. And so sine angle, which is d over 2, equals opposite, which is 10, over r, which is your hypotenuse. Okay, opposite over hypotenuse. And that's how the equation for chord basis came to be. And that 20 arc, 20-meter arc, or 20-meter chord is equivalent to 1 station. Then finally, station PC is just station PI. Station PI is this, yan, minus t. So if you're given the station for point of intersection, just solve for tangent length, subtract the 2, you'll get station PC. And then to get PT, it's PC plus the length of your curve. So plus this length. Okay, so it's PC plus LC. Okay, so PC, you're going to start with PI minus tangent length. PT, the end of your curve is from start of the curve, your PC plus length of the curve, LC. Okay? All right, so that's it for the equations. Do you have any questions so far? Please answer in the chat. Okay, no questions. Let's have a few examples. For simple curve. Sometimes the questions are easy. For example, in number 1, a 3-degree curve has an angle of intersection of 24. What is the length of the long chord and the length of the curve? So first, let's start with the given. Degree of curve is 3. So write that D, 3 degrees. Next, let me close that. Next, angle of intersection 24. So that's your I. Next, the question is length of long chord and length of curve. So we're looking for L and LC. Now, let's look back. Equation for L is 2r sine I over 2. Equation for LC is IR. So I have I, so no problem there. The problem is I don't know R. So now the goal is to get R. Now let's look at our given to see what we can use. We're given D, degree of curve, and we have an equation for that, which is the following. So I can use any of those two to solve for R. Now, usually, if it's not given in the problem, we're going to use arc basis, okay? So take note, if it's not given in the problem, we're going to use arc basis, okay? So arc basis 20 equals RD. Let's use that. 20 equals R. Degree of curve is 3. Now take note, if I haven't mentioned it before, whenever you have an angle outside any trigo function, it should be in radians. Always convert to radians. This is a degree outside any trigo function, so I gotta convert. To convert to radians, just multiply it by by pi over 180 degrees. Okay? And then from this, please solve what's R. Correct, John and Kian. So 381.97. Store that in your calculator because we're going to use it. And then now we can solve for L, C, and L. L is 2r sine I over 2. R is this, so 2r sine I is 24 over 2. Please solve. What's the answer? Correct. KB and Kian, Escobar, Kiben. Escobar, Kiben. So 158.83, that's our answer. Don't forget the unit, meters. If we're using arc basis, chord basis, our units are in meters. And then LC is just IR. And remember, I is 24 degrees outside a trigo function. So I gotta convert that to radian. So multiply by pi over 180, then R. Please solve. What's the answer? Correct, Geraldine. And Jericho. Lazaro. Okay. 160. So 160 flat. And that's it. So problems like this only need direct sub and a few more computations. Now let's move on to another problem. Problem number 2, which is a bit more complicated. Example 2, a simple curve connects two tangents that intersect at an angle of 30 degrees. A point P on the curve has a chord length of 42.8 meters from the PT, and the deflection angle from the forward tangent to the same point is 4 degrees 20 minutes. Determine the middle ordinate. We got us to solve for middle ordinate. Let's figure out how to get that. So middle ordinate M is R times 1 minus cosine I over 2. We're given I. So once again, the problem here is getting R. Okay, so let's write out our given. And two tangents that intersect at an angle of 30 degrees, that's your point of intersection. So that's your I. That's why it's given. Next, at point P on the curve, it has a chord length of 42.8 from PT. So we gotta draw this curve because we can't just create equations from imagination. It's easier to draw this. Okay, so then we pull up a simple curve. Yeah, copy that. Okay. So let's, for example, I have a figure of a horizontal curve, a simple curve. Okay, usually you have to manually draw that using doing this. But to save time, I already have a figure. Okay, so what's given here is point P, 42.8 from PT. So this PT gotta draw a point over here. Yeah, let's say here, this is my point P. Draw a straight line, and that length is 42.8. Okay? And then another thing that's given, deflection angle from the forward tangent to the same point is 420. So deflection angle, forward tangent, this is the forward tangent, this is the back tangent. So from here to point P, that's this angle over here, and this one, that has an angle of 4 degrees, 20 minutes. Okay? What else? So nothing more. The question here is getting the middle ordinate. And we've already established that to do that, I need to get this length R. And this is also R. Okay? If I draw a straight line from P to the center O, that's also R. So one way to get that is to remember one thing about chords on a circle. Okay? If you have a chord here, and I draw a line from the center of my circle bisecting that chord, so meaning this is half of 42.8, half of 42.8, it also bisects this angle, okay? And this angle is equal to 4 degrees, 20 minutes as well. Okay, this one. Okay, 4 degrees, 20 minutes. Now, you might be wondering, how come? Recall we had a theorem about perpendicular angles. The angle between two perpendicular angles are equal. So let's check. Okay, so these are the lines of this angle, okay? This line, perpendicular to this line, right? Because this is a radius, always perpendicular to your tangent line. And then we have this chord, this is a chord, and this is a line bisecting that chord. Another thing about bisecting lines passing through the center of your circle is this also perpendicular to that chord. Okay, so these two are perpendicular to each other. So angle between them are equal. So this is 420, this is also 420. Okay? And so that's the reasoning behind that. So let me isolate that drawing. And this is your R. And this is your angle. This is your chord divided by 2 over here. So 42.8 over 2. And then this is 420. But from this drawing, you can see we can solve for R. Using sine theta, so sine 40 degrees, 20 minutes equals opposite, which is 42.8 over 2 divided by hypotenuse R. From this, we can solve for R. Please compute. What's the answer? Correct, Denzel. And Angel. Salika lang. So it's 283.22. So store that because we need that later. And then from that, we can solve for M. Now recall M. The equation for M is R times 1 minus cosine I over 2. So R, which is this, 1 minus cosine I is given 30 degrees, 30 over 2. Please solve what's M. Correct. Geraldine and Jasper. Viernes, Lazaro. Okay, the answer is 9.65 meters. Okay, don't forget the unit. And that's it for number 2. Do you have any questions? Please answer in the chat. Okay. Angle again. All right. So if we have two perpendicular angles, the angle between them is equal. Okay, that's just one of the theorems. So for example, if we have this, and we got another angle, so let's draw a straight line perpendicular to this side. And then let's draw another line perpendicular to this. So let's say here. And this angle is equal to this angle. Okay. So that's a theorem of perpendicular angles. And then, checking here on our drawing, are these two lines. Okay, let's choose a different color. This one, your tangent line, and this chord is what comprises or what subtends 420. And then the two lines subtending this angle are this one, and this one. This line is perpendicular to your tangent because radius is always perpendicular to the tangent line on a circle. And then this chord, this line is perpendicular to this chord. Okay, because of your angle bisector theorem for circles. If a line passes through the center of the circle and bisects a chord, that line is also perpendicular to that chord. Okay, So this and this perpendicular to this and this, therefore angle between them is the same. For 20, this also for 20. Okay, does that explain why they are equal? Okay. So take note of your perpendicular angles, and that can help you figure out what the value of the parts of your circle or simple curve are. Next, paano malalaman kung need siya i-convert to radians? Anytime your angle is outside a trigo function, always convert to radians. For example, here, 24, it's not within any sine, cosine, tangent, cosecant, cotangent, secant, so convert to radians. This angle is within your sine, so no need to convert. This angle, 30 degrees, within your cosine, so no need to convert. What else? This, 3 degrees. It's not accompanied by sine, cosine, tangent, etc. So I need to convert. And so keep in mind that rule. This goes for any subject, math, physics, or other design courses if you have any. This applies to everything. If you have an angle outside your trigo function, always convert it to radians. Okay? So, yun. So that's 1 and 2. Let's have another example. Number 3. Okay. The deflection angle of two intermediate points A and B of a highway curve are 5 degrees, 15 minutes, and 10 degrees, 15 minutes respectively. The chord distance between points A and B is 20 meters, while the long chord is 150 meters. Stationing of PI is 8 plus 060. Find the stationing of PC and PP. Let's start by writing what's given. Deflection angles of A and B are 5, 15, 10, 15. I can't just write that, so that means I have to draw my simple curve once more. Next, the chord distance between points A and B is 20. Again, that's part of the drawing. Long chord, 150. Oh, we can write that. Long chord, which is capital L, 150. What else? Stationing of PI 8 plus 060. Okay. Station PI. So we're gonna encounter these types of markings often. So that just means 8 kilometers, 60 meters. Okay, so we divide it by kilometers. Okay, so this is just kilometer meter. Okay, so that's how we write stationing. We're looking for station PC and PP. Okay. We have this. This is given. Stationing of this. We're looking for these two. Stationing of PC. Okay. Stationing PC and PP. Okay, let's write what's given. I'll draw it. Deflection angles of A and B are 5 and 15. So they're not given from if they are from the back tangent or for forward tangent. So that means usually we're starting at PC for deflection angle. So that means we're starting with the back tangent. Okay. So let's choose a point A. Let's say here. This is my point A. So deflection angle, draw straight line passing through A. And that angle is, again, deflection angles are always from the tangent, 515. And then another point, B, has a deflection of, so let's draw a straight line. This entire thing is 10 degrees, 15 minutes. Okay. This is point B. Okay. Chord distance between A and B is 20. So draw a straight line, that's 20. So let me just move where A is. And this is A. Okay. So that's a chord distance. The question is station, PC, and PT. Okay, this is PI. So to do that, we're gonna base, remember, we can start with PC. Station PC has this equation. It's Pi minus T. So the goal here is to get the value of T since Pi is given. And T has this equation, R tangent I over 2. We don't have R and we don't have I. So that's where we'll start with, R and I. So let's draw a straight line or a radius at these points as well, right? Center to any point on the curve, those are also your radii. So that's R and R. This is 20. Okay. This is 5. This is 10 degrees. So like what we did earlier, okay, in order to create an equation, I'm going to draw another angle bisector here. Okay, because as it is, this triangle doesn't have any much properties that I can use to solve for theta. Okay, but if I draw a straight line, we can create a right triangle. Okay, so if I can just get this angle, I know this is 10 because this bisects your 20. So this line is 10. If I can just figure out what this is, I can solve for R using sine function. Okay, to solve for that angle, we're going to look at what's given. Okay, first of all, this is 5 degrees, 10 minutes. Therefore, this is 10 degrees, 30 minutes. How do I know? Let's look at the parts of our circle again. Parts of our simple curve. If you can see here, this is your deflection angle theta. Okay? To this point. And then if I draw radius of that point, or from that point to your center, then this angle is 2 theta. This is theta, this is 2 theta. Okay? So that's one property your simple curve has. So we can use that to our advantage in solving for what we need. So this is 5, this is double that, 10, 30. In the similar fashion, reflection angle from tangent to B is 10. So angle from this radius to that point, okay, so this is double that. So that's 20, 30. 20 degrees, 30 minutes. Okay? And then, using that, if I get the difference between the two, we can get this angle. So 20, 30 minus 10, 30, that's just 10 degrees, right? And then finally, this line bisects this angle. So this is just half of that. So that's 5 degrees. 10. So now let's isolate that drawing. So this is your R. This is that 5 degrees. And this is 10. Okay? Because once again, this line bisects this angle and this chord. So 20 divided by 2, that's 10. And then 10 degrees divided by 2, that's 5 degrees. And then using sine function, sine 5 degrees equals opposite, which is 10 over R. We can solve for R. We solve, what's the answer? Correct. RDL and Colleen. Rapid Sante. 114.74. Store that. Now I have R. The next goal is to get I. Solving for I. Now we have one given L. If you remember, the equation for L is 2R sine I over 2, right? I already solved for R. I'm given L, so I can use this to solve for I. So let's plug it in. 150 equals 2. This is R, so use the stored value, sine I over 2. From this, please solve what's I. You can write it in decimal. Correct, John? And Gabriel. 81.64 degrees. Okay. So now remember, our goal here was to get P. Right? P is r tangent I over 2. Okay, so let's solve. R is this, I is this, what's P? Correct, Geraldine? Lazaro. And John. What is that? It's 99.10. Okay. And then from that, we can solve for station PC, which is again just station PI minus P. And then let's rewrite station PI instead of 806. What's that? 0. That's 8,060 minus 99.10. What's the answer? Correct, Gabriel and Jasper. Viernes ang fun. So that's 7960 from 0.90. And then to get the final answer for station, that is separating the kilometer. So that's 7 plus 960.98. So that's how you write stations. Okay, so that's station PC. Next, to get station PT, that's just PC plus length of curve, LC. So now the goal here is to get LC, which is equal to IR. And I have both. But remember, I is outside a trigo function. So I gotta multiply that by pi over 180 first. And then multiply by R. Please solve. What's the length of the curve? Correct, Angela. And Gabriel. Some fun for them. Some fun for them. 163. I believe if you use the stored values, you should get 148. And then store. And then finally, station PT is station PC plus LC. So use this, add it to this. What's the answer? Correct, Maria and Geraldine. So that's 8,124.38. And then to write that in station form, that's 8 plus 124.38. And that's it. That's how you solve for stations. Okay. So that's number 3. Do you have any questions? Please answer in the chat. Ma'am, bakit nag-start sa PC yung angle? Okay, so conventionally, when you're doing this on the field, you're gonna start with PC. That's why it's also called the beginning of your curve. Okay, so you're gonna plant your theodolite at PC. They got a theodolite or something over there. And then establish where your PI is. So it's over here. Okay, site PI, that's where your tangent line is. Okay, and then you're gonna rotate your theodolite a certain angle to get the first point on your simple curve. So let's say here. Okay, you rotated from sighting your point of intersection to this point. That's what we call your deflection angle. Okay, so that's why it started from PC. If it's not mentioned in the problem, deflection angle starts from PC or starts from the backward tangent. It starts at PT if it's given in the problem. Or if you're doing double angle method where you have a station here and a station here. Okay, but if it's not given in the problem, we can assume that it's at PC or starting with PC. Ma'am, clarify ko po sana yung 5 degrees is nakuha from subtracting 10 degrees 15 sa 5 degrees 15. No. We got that because first, if you have a deflection angle here, the corresponding angle here is twice that. Okay? So, on the same point, okay, backward tangent to that point is angle theta, and then radius to that same point is twice theta. And then, for example, here at B, angle is 10, 15. So from radius here to that point, B, twice of that. So 20, 30. Get the difference of these two, you'll get this angle. So 20, 30 minus 10, 30, that's 10. This line bisects this angle. So this divides that into 2. So that's why this is 5. 10 divided by 2, 5. Okay? Yes. Hmm. And let's see if we can do that, what you said. Hmm. I don't think we can use the difference between the two to get 5 because I don't see any perpendicular angles. Okay. For all my understanding, I went through this. We can check. Maybe it is a difference between the two. We can check using your theorems of angles. Okay. But for now, that was the method. So that's simple curve. Since you don't have any questions for simple curves, let's move on to compound curves. Okay. So give me a minute. Compound curves consist of two or more circular curves between two main tangents joined at point of compound curve or point of compound curvature, which is your PCC. Curve at PC is designated as 1, so your R1, L1, T1, etc. And then curves at PT is designated as 2, so your R2, L2, T2, etc. So from the name itself, it's just a combination of two simple curves. This is a simple curve 1, and then there's another simple curve over here. Okay, so this is your R1, R1, R2, R2, L1, L2, T1, T2, T1, T2. Okay, remember for simple curves, back tangent, forward tangent are equal. So for these, that's not the same. We have a longer tangent, a shorter tangent, a longer curve, a shorter curve. Okay, so they're not equal to the other curve. T1 equal to T1 over here, but they're not equal to T2 and T2 over here. Okay? And then we have a new part to your curve, which is your PCC, which is just the point of intersection of your two curves. Okay? And then, if we extend the back tangent of the first curve and the forward tangent of the second curve, this forms the angle of intersection, which is just also the summation of your angle of intersection of curve 1 plus angle of intersection of curve 2. So considering this as a single entity, single curve, and right, it has its own angle of intersection, I1. Same thing here with this second curve. It has its own angle of intersection, I2. Some of that is the angle over here. Okay? And then all of the equations are the same for each individual curve. Now, we have other equations here. Given stationing of PC, station PP is station PC plus LC1 plus LC2. So it's similar to the previous equation where PT is PC plus LC, but here since we have two curves, we have to add both the length of curves, so LC1 and LC2. Now, if what we're given is stationing of PI, okay, so that's station PI minus X, which is the distance of the first point of intersection to the combined point of intersection. So this is your X. And then P1, tangent length of your first curve, plus LC1 plus LC2. So basically, we want to go back to PC. And remember, the equation to go back to PC is from PI minus the tangent length. So it's almost the same here. To get to PC, it's PI minus this entire length. Okay, minus this, which is just X plus T1. Okay, so PI minus X minus T1, that's how you get to PC. And when you get to PC, you're just going to add L1 and L2. LC1 and LC2. So station PI minus X1 minus T1 plus LC1 plus LC2. All right, so that's our equations. So now let's solve. Example 1. A long chord from PC to PT of a compound curve is 180 meters long, and the angle it makes to the longer and shorter tangents are 12 and 18 respectively. Find the difference in radius of the compound curve if the common tangent will be parallel to the long chord. Okay, let's draw that. So this is a hint on how to draw that. Common tangent parallel to long chord. This is what we call your common tangent. Okay? Because they lie on the same horizontal line or on the same straight line. And this is your long chord from PC to PT. So they should be drawn in a parallel manner. So let's do that. Compound curve. Okay? So start off with your back tangent. Okay? And then draw a horizontal forward tangent. And this part is the back tangent of your second curve. Okay? So like that. And okay? So they're gonna, let's say, intersect at that point. Okay. And then your long chord is parallel to that. So here. Okay? So let me change that. Okay. Okay. So this is your long chord L. This is T1. T1. So kind of roughly estimate the same length on each side for the T1. And then the remaining side, that's your T2. T2, T2. And then this is your long chord. This is your PC, the start of your curve. This is where they intersect. This is your PCC, and then this is where it ends, PT. And then try to draw a curve reflecting that. So like that. And then, okay. And then downward over here. So that's your curve a bit. And then let's draw our radius. Okay, so remember radius perpendicular to your tangent. So this is a horizontal line, perpendicular to that is a vertical line. Okay. And then draw other vertical lines to that radius. Okay, so that's your two curves. This is your R1. This entire length is also R1. Okay, so let's draw a marking there. And then the shorter ones are your R2. Okay, so that's your curve. Next, let's write the given. That entire thing is 180. Okay, so this length, the entire long chord is 180 meters. What else? A long chord, compound the angle it makes with the longer and shorter tangents are 12 and 18 respectively. So the long chord to your longer and shorter tangents are 12 and 18. Okay? Obviously, this is the longer tangent, so the angle it makes here from the long chord is 12. So this is 12 degrees. Okay. And then the other one is 18. So from long chord to shorter tangent, this is 18. Okay. And then the question is, find the difference in radius. We're looking for R. Remember, R is equal to, or if you, one equation for R is using the length of chord, right? To get the difference, we have to figure out the parts of each individual simple curve. One way to get R is if we know L, and then we know I, we can solve for R of each. So now the goal here is to get L and I. Okay, so this is the length of the first curve, long chord of the first curve, so L1. And this is the long chord of the second curve, L2. Yeah. Okay, now before I move on to that, let's observe this. We have what we call your parallel angles. Remember, these two are parallel lines, and they are intersected by the same diagonal line. Therefore, angle between them should be equal. So that means this is 12, right? Again, parallel lines. This is your long chord. This is your tangent 1, T1, T1. If this is 12, this should also be 12. Okay, so this is why it's important to remember your theorems and angles. So 12, 12, so therefore on the other side, that's also 18. So this is 18. And remember, this angle, or those angles are actually your angle of intersection I. So now I have I. So the only problem here now is to get L1 and L2. Okay? Now, let's look at the other given. We're given this line. Okay, so I probably need to use that. I need these two. And if you've noticed, we've formed a triangle over here, right? Yeah. If I can just get these two angles, I can use sine law to get L1 and L2 since I'm given this. Okay, so let's start with figuring out those values now. Okay. So let's see what this angle is. Now that is a portion of 12. Okay. Does anybody remember again what's the value of the angle from tangent to long chord. Let's review ourselves. Tangent to long chord. Tangent to long chord is actually I over 2 from this drawing. Tangent, long chord, I over 2. So this is I over 2. I is 12, so this is 6. If that is 6, this entire thing is 12. This angle is just the difference of the two, so this is 12 minus 6, so that's 6. Okay? Right. Yes, correct. KB. That's the ball. And then the other one, you've guessed it, it's 9 degrees. Why? Because similar to that, this is 9 degrees, because that's I over 2, I is 18. And then the remaining angle is just the difference between 18 and 9. So 18 minus 9 is 9. So this is 6 degrees, it's 9 degrees. What's the angle of this? Correct, RDL 165. Okay, so that's 165. And now we have 3 angles and a side. We're using sine law. So using sine law, 180 over opposite angle sine 165 equals L1 over sine, this L1 opposite angle is 9, so sine 9 equals L2 opposite angle is 6 over sine 6. Okay, since we're out of time, I'm just gonna show you the answers. So doing that, L1 is 108.79, L2 is 72.70. Now I have I and L, we can use the equation L equals 2R sine I over 2. So L1 equals 2 R1 sine I over 2. Okay? From this, we can solve R1. So R1 is 520.41. So store that. Next, L2 is equal to 2 R2 sine I2 over 2. L2 is 72.70. I2 is 18. So using that, we can solve for R2, which is 232.35. So just get the difference between the two. That's 288.06. So that's how you solve for number 1. Okay? Do you have any questions so far? Please answer in the chat. How about the others? Please answer as well. Ma'am, kapag po nag-input ako ng 2 variables, 1 unknown and 1 stored value, iba po lumalabas sa answer. What do you mean? For example, what question? Okay, wait. I wasn't recording. So let me record that. So for those who aren't getting the same answer here, and you're just writing this in your calculator and have I as X, then solve for X. If you're having that issue where you get a different answer, you can just manually solve for it. For example, here, the goal is to get I. So that's 150 over 2R. Then shift sign. So shift sign that, and then times 2 to solve for I. Okay? And then there's another question. Ask ko lang po kung pwede makuha yung solution sa quiz. Message me. Message me for quiz solutions. Of course, message me. Okay, next. Any other questions? Clarifications, issues, confusion. Right. So, announcement. There's no field meeting tomorrow. Also on Thursday, there won't be any field meeting. It's just you're gonna do your activity, you're gonna do your report and preliminary data sheet for fieldwork 8. I have not uploaded your preliminary data sheet for fieldwork 8 yet. Or rather, I haven't uploaded the demo video. That's because I got a sore throat over the weekend. I wasn't able to record. I'm done with the drawing. I just have to record now. And I haven't done that yet. So that's why. So I'll try to finish it today or tomorrow. So I'm going to extend the deadline of your preliminary data sheet for fieldwork 8 next week, Monday. However, your report, I believe I've already given back your preliminary data sheets for fieldwork 7. I'm going to put the deadline of that to Saturday, 11:59 p.m. Okay? Okay, so let's move 9. I haven't done demo video for fieldwork 9. Deadline of fieldwork 8 report is this Saturday. Oh, there's lecture on Thursday. What I meant is there's no field meeting on Wednesday and Friday. Tomorrow and Friday, no meeting, no field meeting. Just do your activity, your report and preliminary data sheet. On Thursday, continuation of this lecture. Oh, by the way, I've been getting messages like this. If you haven't answered any activity, exam, quiz, you don't have to message me about it. You can just answer. No need to send me excuse letters. If it's still within the week, you have a week to answer each requirement. The only time you have to send me a letter, proof of why you haven't answered is if you miss the 1 week deadline. Okay, if you haven't answered within the week and the activity isn't available anymore, that's when you have to message me. Okay, any other concerns? Oral report. Since we're almost time, actually, let me online lectures. Are you just gonna create a group report? The oral report, where is it? There. Construction surveys. Just talk about construction surveys as a group. Your grading is individual. This is the criteria. Oral report. So you can create any subtopics about construction surveys divided within your group mates. Okay, message me, the one with the issue about the quiz. Okay, since we're out of time, please send me a message about it. Okay, so we're out of time. During meeting, we're gonna have an oral report during one of our meetings. Okay, so it's real time. All right. So if you have any more questions, you can leave it for Thursday. I'll answer them then as well. See you on Thursday. You may go. Goodbye, class.
Ma'am, thank you po.
Thank you po, ma'am.